Good afternoon, everybody, distinguished panel. Thank you for the opportunity to speak today. I'm Biron. I'm from SCD. SCD stands for Semiconductor Devices, a company located in Israel. As such, I would like to share some insights of our latest year conflicts, specifically focusing on detection of small UAVs that we heard today is a great challenge. It's a great challenge also in India, in Israel, and throughout the world. First, I would like to say some words about SCD to introduce it. Then, I would like to describe the threat. What are we dealing with? Focusing on small UAVs specifically. I would want to discuss the current detection methods and their limitations. And then I want to discuss the proposed solution and the new approach that the world is going to is the benefits of high resolution incorporating AI capabilities. I would like to propose a new concept for small UAV detections and to present one sensor that one detector is produced by SCD that can utilize it and do some short summary. So about SCD. SCD is over 40 years in the global market, actually, of production of IR sensor, IR detectors. We have turnover currently of over $270 million per year, growing about 15 to 20% a year in the last 5 years. Over 650 employees currently. We have the biggest IR fab in the world for IR substrate. We manufacture our own FPAs, our own substrates for the IR detectors. It's quite unique. A great worldwide presence, a huge R&D activity. Almost 50% of our team is R&D focused, oriented, engineers, etc., and 10% PhD degrees. Our headquarters is located in Israel. Our ownership is 50% Elbit and 50% Rafael. We have subsidiary in the USA and another company called Quantum Imaging. Currently, we have, this year, we established a new company. It's called SCD India. It's located in Hyderabad. By the end of the year, we will have some site there, some offices. We'll give some sales support and marketing and application to support all our customers in India. And we have another maintenance center currently in Europe, in Germany. Some of our description of some of our products. I want to see a pen. Oh, here's the pen. Okay, so this is a product. It's very important to understand what we offer. This is IR sensors. We have IR sensors in the shortwave IR, midwave IR, cooled, utilizing indium antimonide, HFM or XBN hot operation materials, and we have uncooled and cooled in the long wave. This is the products we supply. We are currently have a market share of 44% worldwide in the shortwave IR in the defense industry and 24% in the midwave IR. In the long wave IR, we're not so dominant, but we recently launched our 12 micron VGA sensors, and hopefully this number will significantly increase in the next years. This is a short movie just to describe where our products go. We are not making the seeker, but we are in the heart of the system of the seeker. We are the sensor. We are the eye of the seeker. Surface-to-air missiles, all kinds of tanks. We have very significant dominance also in projects in India, in the T-90, in the BMP, and of course, on drones, we have a solution for persistent surveillance, for small, for big drones, also thermal weapon sight and handheld thermal imagers. Most of the known weapon systems in the world utilized our sensors inside them. Focusing today on my talk, I want to describe the threat, lessons learned from the Shahed UAV, the Iranian one, and to describe the challenges in detection. Of course, it has a low altitude penetration, It's very hard to look at it from a very long distance, and of course, radar. Radar is, because of the low altitude, radar is subjected to influence from the terrain, and it has a mobile launch. You never know where's the launch site, so you cannot pre-attack it before it launches. It's slow and simple, so it's really hard to even countermeasure with fast and very advanced solutions at aircrafts and seekers. Because it's cheap, so you can saturate your system air defense by numbers, by swarms. It has minimal RF emissions. We discussed this today also, because they're basically autonomous. They they don't transmit anything, and they have a very low radar cross-section, so it's hard to detect. All the materials being used are not reflected in radars. They're coming from a very long range. You can deploy them for a very long range, which sometimes is easier to detect because it has longer time to react if you can control the territory between the launch pad and your location. But once it comes over your border, sometimes it's very short, for short time for deployment of countermeasure. And it's low cost, mass produced. We discussed it today. Obviously, it's hard to deal with many of them coming at you. The detection today methods are radar, as mentioned. They have radar is great for wide area coverage, but the current threats have very low radar cross section, so it's hard to detect them with the radar. It's not so useful by itself. No RF detection, as mentioned, is passive. It's autonomous. No radio signals coming in and out. It's right by itself, by navigation, by imaging, or inertial. Electro-optical and IR-based solutions are very good for today. The current solutions are based on maybe VGA or HD 1280 SXGA, what's called the resolutions, which is not very high resolution. It's a good solution. You need a line of sight. It's not working in the fog or rain, right? But also the attackers are not very useful in the fog or the rain because, again, they're a lot of the time navigating by image and they cannot see where they're going. Limited range of the EO/IR currently, but I want to discuss the solution, how to extend that. Acoustic sensors are very cheap and very useful for a very short range, but not useful when you have a lot of noise, like from a wind or from urban areas. It's not combat proven. So the current approach is to detect the small drones is a fusion of several systems. You cannot do it in one sensor. And the fusion of the radar together with the electro-optical IR. This is the best current solution available. It's not as simple as using one sensor, but it is what it is. It's a complicated task to do. And utilizing both sensors together gives the best result. As such, I want to emphasize what is the trend currently in the world. We, as a supplier of the sensor, we're working with a lot of companies. Of course, we have our own needs in Israel, and we are currently developing the most advanced solution to deal with a threat that is currently hurting us daily. So the trend is to going with this radar and electro-optical IR sensors, but you want to improve that solution. Improving that is having more pixels on the target. When you have more pixels on the target, means you have more resolution. You're using a high resolution sensor. You can, first of all, increase your field of view slightly. You can, of course, increase your ability to distinguish between false alarms and or friendly drones or enemy drones or attackers, and you can do better cueing for countermeasures because you know more accurately where the threat is coming from because each pixel has a narrow IFOV, and you know exactly or almost exactly what the direction is coming from. A large number of pixels also allows you to better implement having AI detection algorithms, again, discussed today in some cases. And AI-based can help improve the low contrast, the natural low contrast that you get from very far away threats or very light signature threats. They can better distinguish than the human eye, and they can cover a large field of view or multiple sensors together, what a human being cannot do. Also, you get it in real time and immediately. It can better separate, of course, the false alarms and the friendly UAVs. It can better classify. Human beings having very hard time to classify what he's seeing, but AI easily can do that, naturally reducing the false alarm rates. And it continuously improves because the AI algorithm learns from its own experience and improves its capabilities. So the combined effect of AI with IR sensors, with high-resolution IR sensors, transforms the IR configuration to the primary sensor in detection small drones. At this point, I want to propose a concept that's the next stage of utilizing high-resolution IR sensors inside this kind of a setup using basically two IR cameras with a known distance, and by doing good registration between the pixels of the two sensors and knowing the location between the two sensors, you can determine also the distance of each threat. So for example, if a swarm of drones coming at you, the system, with help of AI, in real time can determine what is the distance of each drone and queuing better countermeasure. Maybe some people will take it forward and thinking about this idea because it's something is discussed and seems like a rather cheap solution, although each sensor is more expensive, but by covering a larger field of view, you need less of them. So if you want to protect a large border, such as the one that you have here in India, more than Israel, of course, so you don't need as much sensors as shorter distance and smaller field of views. We at SCD, our current state-of-the-art, highest resolution sensor that can be utilized for this kinds of setup is the crane. What we call it's a 5 megapixel. It's the best, currently the highest resolution available in the market. It has a 5 micron pitch. Each pixel, in our terminology, pixel size is the pitch, is the 5 micron pitch. It works in the full mid-wave band. It's a cool detector. Because it's a cool but hot, what we call hot, it's high operating temperature. It's not like a traditional indium antimonide that works in 80 Kelvin. This one works in 120 Kelvin. It has a larger MTBF, mean time between failure. Thus reduces significantly the cost of repair and maintenance. It also has a high frame rate.
We have 1 more minute.
Yeah, I need 1 more minute, thank you. 140 hertz in the full frame, or you can use what we call binning, is putting several pixels together, acting as one pixel, and increasing their sensitivity. I want here to show another example how AI can really support with the detection of low contrast. In this image, on the left side, you can see the real image of IR detection. There are 3 drones here. It's kind of hard to distinguish. If you look harder, you can see them. But the AI easily detects, it can easily enhance the contrast of the threat, and of course determine what it is. And the lower one, it's even harder. There's 3 actually. One is really small, going around this area. It's really hard to distinguish by by our eyes, but the AI algorithms can do it easily. So as a summary for today, I discussed the threat and the challenges, the current solution and the limitations. The approach, the advanced approach currently is going to higher resolution thermal sensors with higher sensitivity as much as possible, and introducing AI to high resolution sensors, IR sensors. Of course, crane, the crane is currently the highest resolution sensor available on the market. Okay, thank you.